Today's lesson is on zeros of a polynomial function. To start, take a moment and complete the warm-up. So this warm-up is when you factor a function, specifically a polynomial function, using two given factors. Okay, just to talk through this one real quickly, then I'll let you complete it by yourself. First, I checked the factor of x plus 4. Because I checked the factor of x plus 4, I know my synthetic divisor is going to be negative 4. This comes out to be a factor. Then I used what's called the depressed polynomial. I tested the next factor of x minus 5 with a synthetic divisor of 5. This is also a factor. So knowing those two things, I know that my final answer, is the two given factors, x plus 4 times x minus 5, multiplied by the remainder, multiplied by the expression left over after you check the last factor. So take a moment, make sure you can complete this by yourself. Next, we're going to talk about the rational zero theorem. So the rational zero theorem describes how the leading coefficient and the constant term of a polynomial function can be used to determine a list of possible rational zeros. And I'm going to skip reading over this for now. I want to go over an example. I think it will make more sense once you see one of the examples. So I'm going to start by going over number 1. And while I go over number 1, I'm going to reference these 5 steps. The first step is to arrange the polynomial in descending order, making sure you have every term. That means we need to make sure we have an exponent of 4, which is what we start with. Then we have 3. We need to have an exponent of 2. There's our exponent of 1, and then no variable at all. So I'm going to start by rewriting this expression as f of x is equal to x to the 4th plus 4x cubed. I'm going to add in my 0x squared minus 12x minus 9. All right, once I identify the polynomial in standard form, step 2 says to write down all of the factors of the constant term. These are the possible values of p. Factors can be both positive and negative. This number right here is considered our p-value. And we need to list all factors of negative 9. So we have to list positive and negative factors of this term. So these factors would include positive and negative 1, positive and negative 3, positive and negative 9. All right, this was step 2 listed above. Step 3 tells us to write down all the factors of the leading coefficient. These are the possible values of q. Factors can be both positive and negative. All right, so the value of q is 1. We didn't write that, but we know that it exists. So 1 right here is going to be our q value. Factors of 1 which is our q value, are going to be positive or negative 1, and that's it. So those are the only factors we have of the term Q. All right, for step 2 and 3, we're finding factors of the term P, your constant term, and the term Q, your leading coefficient. For step 4, you need to write down all possible values of P over Q. Remember that factors can be negative. They both have to be included, so both your positive and negative values have to be included. You want to simplify and eliminate duplicates. It's going to save you a lot of time, so make sure you do that. So next I'm making a list of P over Q, factors of P over Q. So I am going to list, I'm going to start with this number. So I have plus or minus 1 over plus or minus 1. This one's going to be easy because we just have one value of Q, so we only have one denominator. When you have multiple denominators, this list gets quite long. All right, if you have plus or minus over plus or minus, we could just include that once. So we have plus or minus 1 over 1. Next, we're going to do plus or minus 3. So we'll have plus or minus 3 over 1. And next, we're going to do plus or minus 9 over 1. So if I simplify this, obviously any number over 1 simplifies to itself. So we're going to test plus or minus 1, plus or minus 3, and plus or minus 9. These right here are considered your possible rational zeros. So we don't know if they're actually the zeros, we just know that they're a potential. So this is a potential answer. So I'm just going to write as a keynote that these are possible solutions. We don't actually know yet. We need to test them. So now you're going to perform synthetic division for every one of these factors until you have your expression completely factored. I always start right at the beginning. So I start with positive 1. That's this number right here. Then I'll do negative 1. Then I would do positive 3. Then I would do negative 3, and so on. So I'm going to start my synthetic division by putting my factor of 1 outside. Inside, I have my coefficients of this expression. 1, 4, 0, negative 12, negative 9. And when I test this, I bring down the 1. 1 times 1 is 1, plus 4 is 5, times 1 is 5, plus 0 is 5, times 1 is 5, plus negative 12 is negative 7, times 1 is negative 7, and then negative 9 plus negative 7 is negative 16. So no, this factor is not a 0. Remember, if it's a 0, the remainder has to be 0. All right, so we just tested positive 1. Now I'm going to test negative 1. This process gets tedious because you can be testing a lot of values. All I can tell you is take your time, make sure you don't skip any. Hopefully you get to your answer fairly quick, but you are going to be doing a lot of synthetic division for problems like this. We're testing negative 1 in our original function. 1, 4, 0, negative 12, negative 9. Bring down the value of 1. 1 times negative 1, negative 1, plus 4 is 3, times negative 1 is negative 3, plus 0 is negative 3, times 1 is positive 3, plus negative 12 is negative 9, times negative 1 is positive 9, which is 0. This right here is what we want. So we can say yes, x equals negative 1 is a solution. But specifically based on the directions of the problem that say to list all possible zeros and then determine if it is a zero. Okay, the directions don't say to factor actually, but I'm going to add those in just so we have it as an example and factor. So I'm identifying zeros and I'm factoring. Okay, here's the first part. So we know that x equals 1 is a solution. If we know that x plus 1 is a factor. Of course, if you set x plus 1 equal to 0, you would get x equals negative 1. So these are the two key pieces of information we're looking for. All right, because we're trying to completely factor this and we want to find all zeros, we need to keep going. So we have to keep using synthetic division. Once you find a factor, you can use what's called the depressed polynomial. So use this, it's going to save you time. That means we're testing our next factor. We just tested positive 1, we tested negative 1, so those are all set. Next, we're going to test positive 3. We're using the depressed polynomial. 3 goes outside. Inside we have 1, 3, negative 9. Bring down the 1. 1 times 3 is 3. 3 times 3, 3 plus 3 is 6. Times 3 is 18. Minus 3 is 15. Times 3 is 45. And we instantly know this is not going to work. So this one is a no-go, not a solution. Next, we're testing negative 3. Same thing, use your depressed polynomial. 1, 3, negative 9. Bring down the 1. Times negative 3 is negative 3. Plus 3 is 0. Times negative 3 is 0. Plus negative 3 is negative 3. Times negative 3 is 9, which is 0. And this is what we're looking for. So from this, we know that x equals negative 3 is a solution. And we also know that x plus 3 is a factor. All right, based on this depressed polynomial that we have left over, we could stop right there and we can just answer the remaining question as a quadratic because this is just going to be x squared minus 3. So we can finish this without using synthetic division any further. So I'm going to list my factored form first. I think it's easier to do that. So factored form is going to be f of x. I found this factor, so f of x is equal to x plus 1. Then I found this factor times x plus 3. And then left over was this factor, x squared minus 3. Of course, if you can factor this, you need to. So check for that. In this case, you cannot. So this is your factored form answer. And then the zeros come from this. So the zeros are when you set each factor equal to 0. X plus 1, set that equal to 0. X equals negative 1, which we already know up here. X plus 3, this gives you x equals negative 3. And then if we set the next factor equal to 0, I'm just going to do this up here. X squared minus 3 equals 0. we get x squared equals 3, of which we take the square root, and we get x equals plus or minus the square root of 3. This is an irrational zero. And the directions just say to list the rational zeros. So we're not going to include that in our final answer. However, moving forward in note sheets, so in a couple of note sheets, we are going to include this as a zero. So don't forget about this, just kind of keep it on hold. For now, don't include them in your answer, and then when we get to the complex zeros note sheet, we will start to include them. So for zeros, or for rational zeros, our final answer is x equals -1 and x equals -3. For number 2, I'm going to start off doing this one with you, then you'll just watch me work through all the synthetic division. That way I don't have to talk about the answer completely. And then I'll explain the answer once we get to the end. But to start with, we need to first check to make sure we have all of our values, which we do. In this case, we are all set with that. Next, we need to find our values of P, find our values of Q. So just remember that your P value is this, and your Q value is this one here. We're going to start by listing factors of P. These factors would include positive or -1, positive or -2, positive or -4, positive or -8. You have to list them all. Next, we have factors of Q. Q is a value of 3, so the only factors we have are positive, -1, positive, or -3. Next, we need to list our factors P over Q. And P over Q is what's important because those are your possible solutions. So this work right here is just kind of extra work. And then this right here is what your actual possible rational solutions will be. So I'm going to list 1 plus or minus 1 over plus or minus 1. I'm going to go through all the denominators of 1. Next, I'm going to list plus or minus 2 over plus or minus 1. Next, I have plus or minus 4 over plus or minus 1. Last, I have plus or minus 8 over plus or minus 1. Then I'm going to start again and I'm going to list all of my values with 3 as the denominator, plus or minus 1 over plus or minus 3. Next, I have plus or minus 2 over plus or minus 3. Next, we have plus or minus 4 over plus or minus 3. And lastly, we have plus or minus 8 over plus or minus 3. So yes, these are fractions, and yes, sometimes you have to check fractions. It gets a little bit messy, but it's really not bad. I suggest always starting with your whole numbers. For this, I'm just going to clean up this list. I'm going to list all of my possible rational factors as plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Then plus or minus 1/3, plus or minus 2/3, plus or minus 4 over 3, 4/3, and plus or minus 8 over 3. This here is your answer, or would be your answer, for positive or negative. I'm sorry. This would be your answer for a question that asks for possible rational solutions. And you will get questions like this. So you'll get a question that just says, what are the possible rational solutions? And this is all you have to do is get to this point. You don't need to solve anything. So pay close attention to the directions you see. Now for the rest of this problem, if you guys want to just watch me complete it, I think you've seen me do plenty of synthetic division. So I'm going to start with my factor of plus or minus 1. I'm going to go through all the factors till I have it completely factored. And for this last problem, I shouldn't have broke this apart to separate directions. It's really the same thing. This time the function, instead of it being equal to f of x, I already set it equal to 0 for you. This is the same type of problem. You're factoring it, you're finding the zeros. So I do apologize for separating the directions, but it is the same. So I'll just work through this one. You can follow along with me. Let me know if you have any questions. And And for this on your own section, if you just check my website for the answers, you'll find them all on the note sheet.